Hello, this is Mason Satterfield, and I am going to be talking over the Unified Modeling Language, the test-driven development, and software security. The main purpose of this kind of keynote or this PowerPoint presentation is to try and get you an understanding of what these Unified Modeling Language is, a basic understanding that and a couple of its characteristics. Also, we'll touch base on the test-driven development and some of its characteristics and its parts. And last, we will touch on some of the software security things that will help secure your not only just your network, your software security, but all that kind of security that will help keep your system secure. So, going on to the first point that we will be talking about today is what is UML? Now, UML helps model and document software. To the right here, this is a kind of picture of a UML. We'll look at first this basic structure. This is kind of a class, and this class has its heading of a HR. And then inside it has some details with a plus. There's also a minus to talk about what these methods do. Now, this HR goes to accounting. So this is directed with a relationship of this arrow here. This arrow helps kind of show that relationship. This arrow has different kinds of meanings based on each software. Now, the UML was created to help unify the way we visualize our software systems. The UML was first created when it was in chaos kind of mode around the 1990s. There were several different kinds of software systems during that time. Between the 1994 and 1996 kind of era, they were looking at trying to adopt a unified modeling language, and that's where they came across this UML. And in 1997, that's when they adopted it as a standard. Standard basically is a way that we go about modeling, not just modeling, but going about a process or a system. So a standard for modeling of software would be UML. For a standard in networking would be like using the correct amount of twists in an Ethernet cord. All different kind of standards for different things just mean that you want to make sure that you follow that standard. That is something that is used in our field here. Now, we don't want to get that messed up with best practice. Best practice does not need to be followed, but standards do need to be followed. Moving on to the next part, what is the use of UML? UML has a wide variety of uses, but it's mainly in two different ways. The first one is a business kind of aspect. UML has recently been adopted into that business aspect for its workflow, kind of like a flowchart here. So I'm going to take you over here and show you what's going on. So for this business flow, we have three different categories. We have an employee category, a supervisor category, and an administration category. Now, the way that this kind of flows like a flowchart, but also these relationships show on what's going on. So, starting off here, the employee fill outs that expense form. Sorry about that notification down there. And then we also submit that expense form to the supervisor. That supervisor will receive that expense form, and then we come to this diamond. That means that we will have two kind of forks on where we will go. This fork goes up to if it is no that the expense valids are not valid, then they will notify this employee. If it is valid, then the supervisor will submit that authorized expense form, which will take it down to the administration. The administration will receive that expense form, and that expense form will then be logged in the administration, and then that will make that payment on that expense form. Once that expense form is done and paid, they will notify that employee. As you can see, this is kind of looks like a flowchart, but also kind of a UML by the way it is set up with these categories. So the second part of that UML, like I said, it also benefits software engineers. It creates that consistent and easy to understand code. That means, like before, it is a unified language that should allow anyone to come up and see what's going on with that language, that modeling language, and should help you understand what's going on in the code and what you're trying to get at. Sorry about these. Let me get this turned off. There we go. So moving on to the next part, kinds of UML. There are two different main categories of UML. We have behavioral and we have structural. Now, looking at this, there's about a couple kinds of diagrams. You have the composite structure, the deployment, the package, the profile, object, the component. All these structurals have different kinds of structures, but all are around the same kind of way they are set up. Now, behavioral diagrams, this is based off of kind of the way that it flows in the behavior of what's supposed to happen. That can change drastically, but the structure is all based on the structure, meaning not much changes here compared to here. For that behavioral diagram, we have a state machine, we have communication, use case diagrams, activity, sequence, timing, interaction. The main ones that I'll be talking about in this presentation today will be that class diagrams and those use case diagrams. Those are widely used in software engineers to help model our relationships and our objects. Use case diagram. Use case diagram helps depict what the expected behavior is and helps summarize some of those relationships. It does not, however, show the order of steps performed to reach this goal. So what I have here is a picture. It's a little bit distorted, but we still get the idea here. It was created by my professor, and what we have is we have two people. We have a girl and a boy, and they are related to this find honey use case. Now they're related by this line. This line kind of depicts that this boy talks to this find honey, and this girlfriend talks to this find honey also. This find honey is kind of like a program that'll help relate or help two people of different genders meet, or even two genders together based on how the program is made. Find Honey would be kind of something like Tinder or a dating kind of app. It was just kind of a use case diagram to show what would happen if we wanted to set a program up like this. Now, moving on to the next type of diagram. The next diagram we'll be talking about is the class diagram. Class diagrams is made up of two components. These components are those classes and relationships I was talking about early on. Now, this isn't the full diagram that I took off the web, but I wanted to show a basic kind of comparison because most of class diagrams will look exactly like this. First looking at it, we have this yellow class, and this yellow class kind of shows as the superclass, or the class that will connect these other square bracket classes. Now, these all have kind of methods to help describe, or variables to help describe what is going on. Above here are the variables and below are the methods. So here's where you'll be naming the registration for the car, the year, the license number, and you'll be saying what those variables are for each of those. Now below you'll show the methods. So this will be a move forward method, a move backward method, a stop method, a turn right. Basically, this class diagram helps you set up that code and know what you should be having for each class. User story. User story is not something that's typically correlating with the UML here, but it is something that you will need to understand how you will set up your code. User story is basically the foundation of what needs to be accomplished, and this can be looked at as that background information. So for one of my classes, I set up a user story. Now, user stories can really be anything on how you set it up. So this is what I set up. Ruby, which is my husky dog, I said this dog would like to join the pet club. Ruby asked the animal club if they could ask the pet club if she could join. The animal club agrees to speak to the pet club for Ruby. The pet club asks for the time to see if space is available. And then we have two options. Space is not available, or space is available. If the space is available, then they will add Ruby to the pet club. Next, the pet club gets back to the animal club, sets up a date to have Ruby introduced to the club, and Ruby has fun at the pet club. Now, obviously, you see here, I set it so that Ruby is available, that there is space available for Ruby to join this, and that's how you would set up. Now, if you were going to set up a code that wanted to test all the possibilities, you'd want to set something under the space is not available, but for this type of story, I only had it so that space was available. Test-driven development. Test-driven development is where you create the test code before you create the body code. This will help you test that code that you implement to make sure that it helps create that best design for consumers and business needs. This will make sure that you don't have any kind of error or that you don't add too much stuff that is not needed that will make sure your code is running efficiently. The test-driven development background. TDD for short uses two things to develop the software: the user story and use case diagram. Now we just talked about those. Between those two kinds of relationships, you should be able to create a code that helps create this test and helps show the way you want your code to be set up. Test-driven development. There are two levels to this test-driven development. There's the acceptance, and then there's the developer. Now, the acceptance one, this is where you will start at basically adding in an acceptance test. Now, you only have one option to run that acceptance test. It'll rather pass that test and you create another one, or it'll fail. So if it passes, we go back, we run the acceptance test again. If it fails, we'll go down and make a little change. Now once you make that little change to try and get it to run correctly, you can rather run that acceptance test again, or you can go to the developer TDD. Now, let's say we run that acceptance test just at the acceptance TDD. It fails, we go back, and again, we run that acceptance test. So let's go to the other fork in the road, to the developer TDD. Now, for the developer TDD, they will add a developer test based on these acceptance tests. If this test runs and it passes, then you can add another developer test to test these acceptance tests. If it fails, however, they may make a little change and run that developer test again. Now this has basic three options here. If it fails, you make another little change to make it run correctly. Now if you run the test and it passes, but the functionality is not complete, it's not running how you would like, then you go back and add another developer test and go through that process again. If it does pass that functionality, then you will go from this developer over to the acceptance TDD. This will then run that acceptance test. You run that acceptance test to make sure everything is complete. Then you can, if it passes that development and it needs to continue, and you want to continue creating more stuff for this code, you'll go back to the top and continue adding more things for your code. If the development is over, then you stop and you'll end at this dot. Just a little bit more information on acceptance. Basically, the main idea behind this acceptance TDD is to specify detailed requirements for your code or solution. This is known as a behavior-driven development. This is based off of that use case diagram, which will, that use case diagram, which will show how everything will run based off of the instance. Now, for the developer TDD, with developer TDD, you are creating a simple unit test. That simple unit test will be testing that code or that behavioral design that you set up. This idea is to create a detailed design to test that design. This is mainly what we are using when we are talking about TDD. TDD is basically testing that behavior, and you'll be using this developer TDD to test that code. So, looking at an example, in our class we have a JUnit that we used for our Java, and that JUnit we specified by pulling in this import here. This import imported all of our packages we needed. The author was my professor here, Dr. Jared Oloch. This is where we created the method. We started that JUnit here with our class. The class is obviously on a different code that would be somewhere else, but here for that we're just going to test the basic salary with valid salary. So here we set the basic salary equal to 4,000, and then we set that in. Now now we will set up another variable called expected social insurance, and we'll set that equal to that basic salary times 0.25. Now, what we will do is this variable, we will use our JUnit, and we will use an assert equals method that will help compare this particular variable with our background method that is in the code behind. That code will run, and if it equals each other, then we should have no errors. Moving on, same with expected additional bonus. You'll have that basic salary that you already set up times 0.1, and you'll see if this variable is equal to the method that we set in the background, which should have this dot get additional bonus should be returning us this expected additional bonus. Now, again, if there's no errors, we go down. Expected gross. This will equal the basic salary that we set above, the expected social insurance, and then plus the expected additional bonus. So they added this, and that'll get us the expected gross. We check that variable, the expected gross, with our method behind. That is our dot get gross salary. If they equal, then we know it is correct. Moving on to a scenario where we will have an invalid answer. So this one we're doing test basic, a void method that tests the basic salary with invalid salary. So we have a basic salary set to -100, and in the back of the code we have it so that if the code is less than 0, then it'll throw in an argument exception. So here we're showing assert throws, which comes through that JUnit there. That JUnit will test this illegal argument exception class, which comes from this, and see if that not from this, sorry, the illegal argument exception class will pop up based on it being less than -100. And then here, if as long as that throws that exception, then that assert throws will be correct. This is just tearing down that JUnit. Alrighty, so moving on to software security. This is where I touched a lot of base on what securities I think are needed, at least for someone, if they're just getting into security, they need these aspects. So the first 3 basic components that you want to look at when you're setting up security is first confidentiality. Confidentiality is keeping that data and resources hidden from users that should not be able to see that. You want to make sure that no one, unless they are authorized, should be able to see that. Now moving on to the integrity. Integrity, the data integrity and origin integrity, you want to make sure that when this integrity is, or this data is moving, that it is not changed by other users. You want to make sure that you have some kind of flag or something that makes sure that your integrity is not modified, and if it is modified, should be able to note how it was modified and who it was modified from. The last thing you want to look at in security or software security is the availability. You want to be able to enable access to data and resources so that your users can get to them. That means that if something is not cleared, you should be able to clear that up and give that access for your users, because you should be creating a scalable network that allows those things for anyone to access. You should never have any problems with availability. Moving on, network security requirements. So I just want to touch on this briefly. Basically, there's some security policies. Those security policies are the same as above. Those confidentiality policy, integrity policy, and availability policy. Those will help make sure that that network is complete. This policy partition system states there will be an authorized secure state. These states are the system that it can enter, and the unauthorized state is another state that it can enter, which is a non-secured. If we get to this unauthorized state, then the system is in a security violation. That means one of those confidentiality, integrity, or availability policies had been violated, and we should be warned about that on your network. Looking a little at cybersecurity here, just wanted to distinguish between the two. A cyber system is the hardware, the operating system, the application software that work together to collect that process and store that data for you. This may take actions if they are needed based off the cybersecurity. The cybersecurity is the collection of those activities that protect any information system and the data stored in it. This is kind of like those policies I was talking about above. These and models should help keep your system secure through the software, and these will make sure that everything is collected and processed and stored for your data. Software security requirements. Exposure. This is one that you want to look at when setting up your software. It is the value in terms of the time or cost to recreate a lost system or asset. These assets, you want to make sure you know where they're going, and if they have some kind of exposure, how to keep them safe and how to know what it'll cost to keep them running. Now, the next part you want to look at is threat analysis. This is the process of determining the conditions or threats that may damage system resources or make them in an inaccessible state to unauthorized user. You want to make sure that you always don't allow those unauthorized users access to those resources so that they can damage them. That's where those policies I was talking about come into place to make sure that this is secure and that those unauthorized users do not have any permissions. We also will set up those controls and that software security that these are created to help avoid those attacks and to mitigate their damage. Moving on here. Code security. So there are some ways to make sure that even your code itself is set up so that it is not giving information that it's needed to the outside. So using private methods, meaning that these are methods that someone outside the network are not allowed to look at or not allowed to use. These are methods that are internally done by the system and cannot be accessed. You also want to try and use private static variables where possible so that you know that it can't be changed by users to try and gain them some type of information or try to gain them more of some resource. Security goals. Now, regular security goals, as stated above in the presentation, following the standards and best practices are the number one thing you want to look at. Standards are those rules that are set by everyone all the way back from even the beginning of time from humans. You want to follow these standards because they are the correct thing and they are what other humans will understand because they are what's set up. Now, best practices, you usually want to follow those, but if they do not work for your specific case, then you might want to go a different route from that best practice, but usually you want to try and use them for your scenarios. Now, the second part we want to look at here is security goals. And the security goals is understanding your vulnerabilities when creating the code in the software development life cycle. When you're creating your software, you're going to be using some software development lifecycle to create that code and make sure that it is adequate for your users or your consumers. When creating it, you should know what is going on in your methods and what vulnerabilities those methods can leave, and also what those variables can leave in those vulnerabilities. Moving on to the next security goal, you want to make sure that you know how your application will interact with that network and internet. So when it's going out, you want to make sure that it's going through the secured protocols that are set up by the ports and that are set up by the network there inside your network, so that when it's going out, you know that that is being securely transmitted through that integrity policy. Alrighty, so moving on. Security analysis. There are four main parts to this security analysis. The first one is the system requirements elicitation. This basically determines how users need to interact with the system resources. They help create abuser stories that describe these system threats. They also have user treat modeling and risk analysis to determine these system security policies as part of the non-functional requirements. This will also help locate attack patterns that identify solutions to those system security. Moving on to that second part, the security modeling. We talked a little bit about the modeling. You want to make sure that this modeling helps capture policy objectives, external interface requirements, software security requirements, rule of operation, and the description of your security architecture. That security architecture, we talked about those policies, and I just talked about some models that can be set up, like the Chinese wall, to help make sure that your network is secured and your software is secured. This basically provides that guidance during the designing and coding and review of all your code there. Also, it helps with those states that I was talking about, and those unauthorized and authorized states. Basically, it should start and end in that secure state, and if it's ever violated, like I say, we should know how and who violated it, so that we can one, punish that person and fix that problem there. Moving on to measures and designs. Measures and designs looks at the security metrics that should focus on those system dependability, the trustworthiness, and the survivability. This is kind of like looking at a graph of what's going on. So I'm going to give an example of Task Manager here. Task Manager will show you your uses of resources on your system there. So CPU, you see how much CPU is using, how much of your disk is being used, how much of the memory, how much of the GPU, so on and so forth. It's the same for the security and the software. You want to make sure you look at those resources, see how they're being used, and make sure that they're not being overused or not being underused, because then you might be able to cut back and save some costs. Looking at the last thing here, correctness checks. Correctness checks basically are the software verification activities and security test cases that must be traceable to the system security cases. This helps just make sure that everything is correct. These are also logs that are used. The logs are used to make sure that everything that is happening is logged into that information. If we find that error, should be able to report it to us and see what's been going on in those logs there. Sorry, a little thirsty here. Moving on to the next part. Password security. In today's era, passwords are what keep everything safe. If it's like a network key or if it's a password key, all these keys it's a piece of information that you are inputting to know that you are authorized. Passwords are also what hackers go for to gain access to your system, such as a software network system. Knowing how to create a strong password to help keep that data secured so that these hackers won't be able to gain information. There's even websites out there that you can look up set in your password on that website and see what how long it'll take for that password to be cracked. If you get a couple minutes, it's probably not a good one. If you get billions of years, then you know it's a great secured one. Moving on, we'll look at those password security requirements. The first one is you want to make sure you're using information not known about you. You want to make sure that this password is something that someone would not even think about adding in there to try and guess, to try and get that information. You want to make sure that that information is not known to anyone. The second one is make the words make the words that are not in the dictionary. So an example that I had here is $Steelers. So you know Steelers is a football team, but using that S or that $ is kind of a word that would not be in the dictionary, which would not be able to be used to try and crack what your password is. Now, to try and secure these words that you're creating even more, you want to make sure that the word and stuff has 8 characters or longer. If you have anything less than that, it could be easier to crack, but it just depends on these next 3 characteristics. The next characteristic, you want to make sure you have capitalized letters in there, or at least one capitalized letter. This will cause it so that instead of just having one lowercase list to look through, it'll have to also look through that uppercase list. Basically, throughout here, you're just adding in more lists that'll cause the hacker more time to try and crack that password. Moving on to the next thing that you want to make sure your password does, you want to make sure it has that special characters. Special characters are stuff like the pound sign or the @ symbol or the exclamation point. You want to make sure you have that in there just for the same reason above. You're adding in another list of stuff that needs to be looked at to try and crack that password. Lastly, you do want to make sure you have numbers in there, and you want to make sure those numbers are with that special character, with that capitalized letter, and with those words that word that you create that's not in the dictionary. All that stuff combined together will get you a very strong password, and you can test that on that website I was talking about. With these all together, you will never have a password that will take at least longer than a year to crack. And we also have stuff like password aging now in today's age, so that about every month, or depending on your organization, every so often they will make you change your passwords. So as long as that password's always being changed, then you know that they'll never be able to attack that password. Looking at some common password attacks we have in today's day and age. The first one is social engineering. You might have heard this a couple times. Basic definition of this is an attacker tries to trick you into revealing your information / credentials, or tries to gain sensitive information on you that may lead to cracking your password. Social engineering I look at as is someone's talking to you and you're looking at, and they're trying to gain information about you, but they're doing it in a way that they're trying to gain sensitive information. But you may think that they're just trying to gain information about you and your life to try and understand you. That's why you always want to be careful about what information you're talking about with people, and to make sure that they are a trusted source. Moving on to the second part of attacks. The second kind of known attacks are dictionary attacks. An attacker will try different kinds of passwords until they find one that works. Usually it's a trial and error from a list of potential passwords that you might use. That's why we want to make sure that we're not using words that are in the dictionary, because those are the words that they're going to try right away to try and get your password hacked into. The last password attack that we'll be talking about is rainbow table attacks. This is very similar to above, but they are pre-computed tables that contain hashes of the words, meaning your password is saved into a hash or a secured kind of state. And I'll talk about that a bit more on this next slide here. Hashing, or how to keep passwords secure. Hashing is basically the second kind of method, but we'll talk about that one first. It uses an algorithm that generates a fixed array of bytes that helps secure that password with different symbols and different letters to help make it so that if a hacker hacks into the network, he will find this hash, which will not be a direct password. It'll be a password that is your password, but not in the correct setup or the correct way. They'll have to use the hash, which they will not know, to find out what your password actually is. Looking at another way to help secure this hashing even farther is salting. Salting will generate a random string of characters when the password is created, and then it will append that string to the password and then hash that password. Basically, it's just going to generate a random string and help put that random string throughout that password to help secure it even further. Moving on, we'll look at phishing here. I think phishing is another thing because that goes on with your passwords and security. You want to make sure emails are like the new texting in today's age. You want to make sure that with phishing you look at a couple key things here. The first one you'll be seeing in your mail is the subject line. Now in some systems they'll have this external, meaning that it came from a source outside of your organization. So for this email, I'm using my Rockets email. I go to the University of Toledo, so this is my Rockets email here. And external means that it did not come from Rockets, so I already know that this user is someone outside of my network or my schooling. And it says interns needed. So this is trying to entice me in saying, okay, we need interns, and I know that you are someone that might need a job. Now, looking at here, the first thing that I look at is the email address because this will tell me where it's coming from in an organization. Looking at this here, I see Gmail as the organization, which to me already sounds very sketchy. If you're sending from a Gmail, unless it's a personal, I don't think usually any business should send through Gmail. They will have their own kind of organization. So, as for example, my email for my school is at rockets.utoledo.edu. For my work, I work at internet service provider. Theirs is at buckeyebroadband.com. These basically ats will tell you what organization they are in. And Gmail, Yahoo, Hotmail, all those are free email providers given to people. So someone like Anthony Blake could possibly create a email account like this to try and entice me. So between this and that, starting off very rocky, but we don't know if this is a for sure spam or not. So that's where I would click on the email. Clicking on the email does not harm your system. You are just seeing what is the contents inside. You're still on your same server, so it's okay to look at this, but you just want to be very careful. About 23% of recipients open phishing messages. Like I said, it's okay to open it, but you just want to be very careful. So next thing I look at is the kind of setup here. The setup we have is it says, hello, how are you doing? Now, the way I set up emails and the way all emails should be set up, you should start with an opening, like hello, and then on the next line down, then you can start with how are you doing. So this then tells me this is not even set up correctly, so I know this person may not even be a professional. Now, he then starts talking about part-time job, contacting me. I'm contacting you about open position. If you are interested, send your personal email and your mobile number for the job description. That, again, why would he ask for a personal email if he's already talking to me on my Rockets email? For my business, the Buckeye Broadband Internet Service Provider, we worked right on my Rockets email, so no reason to ever go away from something that is secured to a different one. So this right here is telling me they're just trying to gain my personal email and mobile number stuff. Looking at more information, work 4 to 8 hours weekly, and the pay is $200 on a weekly basis. I looked at that kind of rate. That's a $25 an hour to 50-hour rate. That is something that it seems like they're trying to entice me with the rate to try and get me to get that job. He then tries to entice me even farther with saying, we'll be expecting your prompt response. Warm regards. Doesn't even put a comma. So all this, with all of that kind of information I've seen, this just does not look like someone I'd want to contact or even be a part of. And it looks like definite spam, so I would not, even if I considered this rate, I would not want to talk to them. Now, they might also put on attachments for you to look at, say, for the job description. They might put attachments above here. Those attachments you do not want to click on. Those attachments might have a virus or a Trojan horse or stuff like that that could infect not only your computer but infect your corporation's network. So you want to be sure that you look at this and look at that and make sure that these are credible sources from people. And then never click on those attachments, never click on those websites unless you know that this is a person that you should be dealing with. Now, moving on to the next part here, the Internet of Things. The Internet of Things is personal devices that collect data or perform a function to help lower workloads. These, I would look at these as like, you could look at it as a thermometer in the house that's connected to the internet, or lights that are connected to the internet. You could have tons of different kinds of smart devices with today's day and age. But the one I'm going to look at here is smart bulb, like in the background. If your home network is not secured, then hackers will be able to steal this information from your Internet of Things that can be used against you. So let's say, for instance, they hack into your network and they see that your lights turn on at 9 p.m. every night. They then say the sun goes down at 7:30 p.m. They then know between the 7:30 p.m. to 9 p.m. window, your house will be all dark, and that might be the best time that they can try and enter your house. Same with your security system that hooks up in that Internet of Things. They can get access to that and even stop your security system from working, so they could just open up the door there. There are a bunch of things in place now to try and stop those kinds of things. We have stuff like WPA, WPA2. Those are some kind of certifications or methods to help secure your network there. They usually use pre-shared keys or passwords, and that's how they help connect to your network. There's also encryption methods behind those that rather AES or TKIP, TKIP. Those help encrypt your passwords so that they are not seen when traveling through that network there. There are a lot of things in place to help keep it secured, so just make sure you have those enabled on your modem or your router to make sure that you are not getting hacked. Thank you for watching. This was something that I had to do for school, and I thoroughly enjoyed talking about all these things. If you have any other questions for me or concerns, I will have my comments enabled. If you want to look at if you want me to start any other kind of software or security stuff, let me know in the comments, and I may make another video about that kind of stuff. Thank you for watching, and have a great rest of your day.